coming for Cassandra data modeling. To start about me, just quickly. My name is Shehaaz. How I got started with Cassandra. DataStax had a big data developer contest last April, and during finals I randomly found this contest and I joined and I built a deal finding app on Android, and then I was one of the 5 finalists and they flew me over to San Francisco, and then that's where I met Expedia, and I work on the SSL El Paso grid team. It's been 5 months at Expedia. So this talk is, at the end of this talk, I just want to be confident modeling data. So it's just like John's talk in the morning, and I'm using examples from Patrick McFadden, his YouTube videos. So basically a layman's understanding of like modeling data with examples, so you can relax and just like not to stress too much. And this is Twitter. So with Cassandra, you have to know the answers you want to get out of the data before you put the data inside the database. So it's a query-driven data modeling, as John mentioned. And don't worry about redundant data. So don't worry about writing a bunch of writes to optimize for the read. And don't have large partitions. So this is one of the mistakes I made when I made my deal finding app. Like I had like the row, I don't know if you can see, yeah. It's this is the timestamp, and the data was for the deal that the person would post, and this would run out like really quickly after, we'll reach 2 billion really quickly, and it's wrong. So you shouldn't have large partitions. Use CQL. Initially, I used Virgil, which was the REST API. It didn't support CQL. It was using Thrift, so I had to like do everything on my own on the application, which is not good. It's like a funny cartoon. You can't read it, but anyways. And the CQL looks like SQL, so it's just exactly like what John showed this morning. Super simple. And then let's go into an example. So we have this weather station, and they give you this information. They give you a weather station ID, a time, and a temperature, and you have to be able to dash this on a dashboard for the last like 5 minutes, for example. And how would you do it? So the table would look like this, for example. You would have weather station ID and event time. Weather station ID would be the partition key, and the event time would be the clustering column. So what's wrong with this? Because eventually you're going to run out of columns, because you're going to keep on adding event times, and you're going to reach 2 billion. So this is a way, for example, you would insert, very simple, and when you do a range query, you would do like this. So the better way to model it would be to put the date also. So you'd have a partition key with the weather station ID and the date. So after each day, you would roll over and create a new table. And the trick to finding how to set the partition key, I found, was, so what's the data I have when I create the table? Like I have the weather station ID and the date. So that would be the partition key. And the clustering column is what I want to sort by on disk. So for example, if I want to find the last 5 minutes, it's just one disk seek, and I can take the data and put it on a dashboard. And you'd put this ordering thing, and you would order it by descending. So yeah, it's basically what I explained, and this is what it looks like on disk. You would have weather station ID and date would be the key, and everything would be sorted by the partition column, would be the timestamp. So this is the way you would do a range query. I want the temperature from 7/1 to 7/4, and for this weather station for this date. Now let's talk about collections really quickly. Like John mentioned this morning, really he didn't give an example, but so let's talk about set, list, and map, and what's great about them. You can have a dynamic item in a row, so a user could have email 1, email 2, and you could have a list of emails. But the con is there are serialization costs, because when you're reading it, they have to deserialize before showing it, so that would will slow down your application. And the collection must be smaller than 64,000 elements, so keep it small. So this is set. For a set, it's basically you put a curly bracket 1, 2, and the thing I want you to take away from a set is the ordering is determined by the CQL type. So the CQL type here is text, and you make sure that it's ordered by this type 1 and 2. And when you do an insert, you just do add 3, and appends it at the end, and when you do 0, it prepends it in the beginning because it orders by the CQL type. And when you want to delete something, you just do minus that element, and there's no read before write, and it goes away. And list, you decide the order of the element, or the order of the elements. And when you want to append something at the end, you would put +3, and if you want to put it at the beginning, you have to put it before. So, and deleting is the same thing, like I said. Maps are more interesting. Again, it's ordered by the CQL type of the key. So here in this example, you have 1 and 2.
Between collection and list, where do you pick one or the other?
When do you pick? Like
Collection and list.
no collection. No, list is a type of collection. Collection is the interface. And, yeah. So for example, let's look at a map example quickly. Map is very simple. So if you want to delete something, you'd get the key, adding, and if you want to modify it, you want to put it in Spanish, you'd put it like this. So map example. So you have this user with location table, right? And you want to have the user location by a map of user's location by the time you UID. So we want to see where they logged in for a certain, when they logged in, in which location. So remember there was a serialization cost with the collections, right? So you would I set a TTL of 30 days in seconds. So this update would like go away in 30 days, and then you would call the now function, and that gives the time in milliseconds. So you create uniqueness in microseconds. Sorry, it creates uniqueness. And this is the way you would model that problem. So TTLs can be set per insert and per update, and there's also a default TTL per table. Like I was talking with Diviti Patel yesterday, and she was asking me this question, and I looked it up, and yeah, so you can actually set a TTL for an actual table for it to go away, and yeah. So in this example, the user, we give it 1 day expiration for his password, and if you want to update it, we send an update command with a different TTL, and it updates.
So expires after the time to live is over.
The actual column.
The data? Or
Yeah,
the column
the
itself
password
expires?
column. Yeah, password column expires.
When it expires, is it just gone? Or is it still accessible with
Or that password is still
communication
valid, but it needs they need to re-log in, you know? It's
Yeah, but,
the session has expired. I cannot
Is
go
it
ahead.
evicted from the
Well,
network?
it's deleted, I think.
It's forever deleted. So this is a time sensitive data.
Since
That's
you
a big
keep
one.
to back up and
Or
restore.
if you've, like his example was the password that like you can't use the temporary password or whatever.
Or the temporary. I think
Yeah,
we have
temporary.
context problems.
Like you can
Got
consider
it.
next session.
Yeah, I got the concern, but I think, you know, you can't just leave people's password.
Yeah.
This is just temp password.
Yeah,
because
obviously, yeah.
Situations like
Yeah. So replication factor is how many copies of the data I want in the cluster, and consistency level is the acknowledgements you get from the nodes after you do a read or a write. So I'll explain what quorum is, because John talked about it this morning. Is replication factor divided by 2 plus 1. That's the quorum. So if you set a replication factor of 3, your quorum would be 2. So after you do a write, you wait till you have 2 acknowledgements. So there's something called row level isolation, which I found interesting also. So you have, let's say, person has his login is Eric21, and he wants to change it to Eric22 and set a new password. After Cassandra 1.1, it updates both the logging and the password for the same row key, and there's no concurrent read would get like Eric21 and the new password, or Eric22 and the old password. Like both get written or none get written. So which is kind of interesting. It's really interesting, but for example, if you have a quorum, quorums, you got to wait for 2 responses to come back. You got only 1, and there's a timeout. So the client has to do a redo to make sure it writes in, because you didn't get the second acknowledgement from the cluster. So indexing. So in indexing, secondary indexes, like we mentioned it this morning, is evil, and you shouldn't use them. So I'll just give you a quick example, and don't do it. So you have this user table, and you put an index on state, And so, for example, we can do like select star from users where state equals Texas. This is kind of an okay like example because there are many rows that would contain that indexed value. So it doesn't destroy, it's not really bad, but should avoid this type of situation. So when not to use it, when you have something unique like an email address, product ID, or video tag, you don't want to put an index on a video tag because you can tag it like funny, cat videos, you know, grumpy cat, like a bunch of tags you could have on videos. So, for example, this is where you create a tag index for the video. So this is very fast and efficient. So every time the user updates and adds a tag for their video, you would update the tag index with the tag and the video ID. So this is why is this better? Because there will be many distinct tags. So you create a separate index, and because we don't want many disk seeks for a few results. So this is a very the final example I have is so you have a car lot, right? And you want to find a car according to the color, model, and make, right? So you have like 7 combinations. You have color, model, make, and the rest. So an example entry would be Ford Mustang blue, and you want to be able to find like, oh, I want to find all the blue cars. I want to find all the Fords. So what would be the partition key in this situation? So what would be the partition key?
3 separate tables.
You could make 3 separate tables, but a more efficient way you could have it's a compound partition key. So you could do make, model, and color, because the trick of having make, model, and color, because you have this information before creating the table, right? The vehicle ID could change. So there's a trick to think like, oh, what would I choose as the partition key? So something that's unique is the make, model, and color, right? So this is the way you create the table, right? So the thing that Cassandra comes into play is because you want to query for a blue car, you know, specific model, specific make. How would we do that? So you would write 7 inserts for the specific Ford Mustang blue with all the combinations, and like, for example, you put like empty string blue because you want to tag it as blue. So you'd have like all these combinations into it, and when you want to do a search, when you want to read, it's really quick because you can be like, oh, I want to find all the blue Fords, and you'll quickly get it, and you'll sort by this vehicle ID. And you want to find all the cars that are blue, you just do like empty string blue, and that gives you all the blue cars. So it's kind of neat way of doing things. So you use Cassandra's.
Your data well in a way, you know, what if your data was very sparse?
Yeah, I know. Yeah, but this is a specific example.
sure.
Yeah. But this is saying like use Cassandra's like because it's able to handle a lot of writes.
Right.
So use that power it has.
You want to reduce the disk.
Yeah, exactly.
Quick question, can you go back to the settings?
This one.
The same table with just the 7 inserts.
Yeah.
You just put an empty string to make the querying faster.
Exactly. So Ford empty string is a specific entry, so you can search all the Fords by the vehicle ID.
So in the query, you could have just queried by one item instead of providing or you have to provide the other.
No, when you do a query, you can do this. Like for example, the last one in the bottom there, I'm doing like empty string blue, and that gives me all the blue cars. Because when I inserted it, I sent it.
So you didn't skip those columns?
Yeah, because that's the way I wrote it in, right? So when you read it, because you have to give it while you're writing. That's why that's a partition
Yeah,
key.
if I remove it from a where class, does it degrade the performance?
It's not going to find it because when you're writing it with empty. You have to give it something. It's a partition key. It's partitioned by.
While writing it, but while reading it, while filtering it, I'll say, you need to specify all the columns present in the partition key, or you can specify some of the columns.
But it's going to get confused, right? Think about it. Like you would have like, you have to say like, I want nothing blue, and then it gives you.
Okay.
Yeah.
I guess it's not traditional SQL.
He's
right?
doing 1 insert per search permutation.
So, particularly,
Yeah.
2 results here because there were 2 columns that match.
Which one?
So let's say search for blue. There would be 3 columns, right, that match. 3 rows that match. Because you inserted 3 times. One
No, but there's only one that's empty string, blue. Like there's nothing for make, nothing for model, and only blue. So that's the way you can get it. Yeah.
So in fact you're writing to SQL terms another table which contains only.
Yeah, but you're writing to the same table with a different partition key. Yeah.
So basically, it's inserting redundant data for faster queries.
Yeah, exactly. Yeah, inserting redundant data for faster.
So why is this better than the other approach of multiple tables? I don't, maybe you never said it's better, but it's just another way of.
I think it's another way of doing it. I never checked the performance. I wouldn't know.
This is really clever trick.
Got fixed. Yeah.
So would this, would you use this model as opposed to, my application seems to have 3 columns of families, the cars by make, the cars by model, the cars by color, and then put them together on a solid query. But this is more efficient if you know that the queries you're going to generally be doing are for all 3. Is that right?
Yeah, exactly. It makes your application code very simple. When you write your app, it's very easy to find things because you can just, if there's an empty string, just like fill in make, model, and blue and send the.
It just seems like it could get really exponentially out of hand if you had lots of.
Oh yeah, but because only 3 of them. Yeah.
The advantage of doing it this way is you don't end up with one table per combination. Like you can insert like 30, even if you insert 30 or 50 rows in the same table, it's not that big a deal as opposed to needing 50 tables to manage all the different permutations of queries. Like, and it gives you, it's actually really flexible. But this, like, it's gonna be either a lot of tables or a lot of rows in one table.
So for this, if I only write, I only want the blue key without no doing no performance writing, and then it's all the
No, it's going to return you nothing because.
nothing?
Yeah, because you're doing where you have to give it a make and a model because that's the partition key.
So it's different from traditional SQL databases where we can specify part of the primary key. It can scan the entire database.
It's not scanning.
Exactly. So it's checking some table where the data is. If you're not going to provide the partition, all the parts of the partition key so that you can find.
This is semantic stuff. This isn't like where you write into 7 equivalent tables for each query you think you're going to get.
Yes.
It's combination.
Exactly. So it's query-driven development. So you think of like, oh, what are the questions I want to answer before I put it in?
To answer any combination of the search queries.
Yeah.
There's 7 different search queries?
Yeah, there's 7. There's like a list.
Each permutation of search query is already conserved. That's why you won't get the same row back twice because if I search for make and color, it's only going to pull back
Yeah, but it's I guess if you really care about your users want to like answer all those questions, yeah, then you have to do it.
So instead of modeling via normalization or via dimensional model, to model the data based on your query needs.
Exactly. Yeah. You think like, oh, I want to answer these questions. And then you
Have a set of questions.
You basically build
As your unique keys. That way you can.
Yeah. The modeling guys. Yeah, I have the links at the end. I'll give you everything so you can watch. Yeah, for sure. Yeah.
Well, how will you send this?
Like through the event or they'll email you. Like, I'm pretty sure. Yeah. We wish we could do possible.
It's really it's clever.
So don't worry about redundant data and have extra large partitions. So I was going to talk quickly, like a high-level overview of like how writes work, but like a quick overview because he went really in depth this morning. Because I want to like go over it again really quickly. So when a client wants to do a write, they give the row key. It goes into the append only commit log and the mem table, and it quickly sends back the acknowledgement. That's how we can do a bunch of writes, and it quickly sends it back acknowledgement to the client. Like I have the data, it's all cool. And then then it gets flushed into the SS table, which is a string stored table that's inside in disk. And for example, now what happens when an update comes in? When an update comes in, the SS table would be in the mem table. It comes in here, and it sees like, oh, it's because there's a new SS table added. It goes into memory, and they do a merge sort, and that data gets merge sort using compaction, because it automatically does compaction and gets written back into the SS table.
May I ask a question about that? That was the query optimization that you did. That was very cool. Now I'm going to update this vehicle ID. That was a Ford Blue Mustang, nothing Mustang, blue Mustang, all that, right? Okay, now I'm going to update that vehicle ID with, I painted it red.
Yeah.
So do I need to have now updates for the same number of queries because it's no longer a blue one?
But it's same vehicle ID, right?
Yeah, same vehicle ID.
Yeah, so you have to, so this it became blue, yeah, everything that had the color. So you would update this.
You have to delete it. Because blue is part of the partition key.
Oh yeah.
You have to delete all of these.
Yeah, delete, what I said. You have to delete it and then.
Okay. Right.
Yeah, it's the one.
Because that's the only thing that changed.
You can't update any of the columns that are part of the primary. Once it's set because it's hashed to a particular server and location, you actually have to create a new record.
So all those
All 7 of those.
So could you just repeat
Yes,
the answer?
summarize that.
So don't use it.
Yeah, you have to like delete it before updating it. If you want to change the color.
The partition key is make model and color.
Yeah.
If you change it any other way, does it matter? Is it
It's because it maps it to this, right? So make model color. If you yeah. What do you mean?
In the table definition, in the partition key definition.
Okay, this one here.
Yeah. So when would you pick make model color or any other combination?
It doesn't. You mean when you create this?
Does it matter or does it not matter?
I don't think it doesn't matter as you're entering it. Just make sure it maps to.
Of course, you should make sure.
Exactly.
Your color should not be blue.
Exactly.
The color should not be 4.
Yeah, but the order here doesn't matter, right? So
It matters.
it matters. Okay.
Because you can select.
No, he's saying like, could you put like color, make, model? Like,
No, it doesn't.
Yeah. So yeah, when you come here, you don't have to do color, make, model. You could do anything.
Of course.
I mean, you do as an application developer, some people know what you're doing, but other.
Yeah, yeah. Yes, yeah. Things you like.
Does vehicle ID has to be distinct? Like, can I add Ford red 1, 2, 3, 4, or Ford Mustang 1, 2, 3, 4, but red color, not blue color? Can I call that kind of data?
Yeah, you can add it. Yeah, in this situation.
So vehicle ID has to be. It's not a key.
It's not a key. It's going to be sorted by vehicle ID.
I know this is me.
No, but both of them together is a primary key.
Yeah.
So this is the partition key.
See, the way I see it,
Say the same vehicle ID has a different color.
Yeah.
You can't have both. You can't have for the same vehicle ID, right?
so
In
the
this
way I
case,
see
in this case, the data model would allow it.
Would allow it.
Yeah.
Because it's
There's no
yeah.
restriction.
The rest of the group is not hearing this discussion.
Sorry.
We would like to get this.
Sorry, we were just saying it's actually possible at the database level to have the same make and model in there and vehicle ID with 2 different colors. The restriction on the primary key it wouldn't just
Complain.
yeah.
Question: How many items can you have in a primary key in that like make, model, color, region, whether it's been driven by somebody, how many items can you actually throw in there? I mean, it sounds like a nightmare to do, but I'm just curious.
I think it's like 127, if I remember correctly. But
Makes sense.
I don't know why you would want it.
It
It would probably be the worst data model ever.
Absolutely.
and the key that you have to put all of them in your query.
Right.
So if you put many,
Yeah.
Right. Yeah. The thing that makes that work is because you put the empty string in,
Exactly. Yeah.
and that's kind of awesome.
Is there a limit on the primary keys?
No. Well, I mean, it's like you're gonna hit the practical limit a lot more than the technical limit.
Internally, is that primary key just literally a concatenated string of those three things?
Exactly. So it's like the weather station ID and the date I had, example. So it's like one, that's the key, and then everything else is the...
So order would matter.
Yeah.
There's no separator comma or anything, it's just concatenated and nothing between them?
I'm not exactly sure, but like, if you read the documentation, it's like it's in one.
I think it's a colon.
It's colon.
Yeah, like a composite.
Yeah, otherwise you'd have all sorts of weird shit.
And like, to summarize, like I had all my references are in this like link. I'll send it to you guys. So there's like 4 data modeling videos that I based my talk off. Just watch all 4 of them, and there are links to it, and just like they're very useful. So it's very, yeah. So the example that I used, the car make model, is from Patrick, and he actually had it in one of his talks, and he talked about it. So yeah, Patrick McFadden, the chief evangelist of data stacks. And yeah. This was I was going to talk about the read. I don't know. Okay, sure. And then so the read, you would actually come into the key cache, and the key cache would check the row key and see does it map to an SS table, and you would directly go into the SS table and get the data, send it to the mem table, and send it back to the client. If it misses, it goes into the Bloom filter. Bloom filter is a probabilistic data structure. It basically finds where the data is not. Like I tried reading about it last night, and it was really complicating, so I gave up. And then it goes into so it finds it. It goes into SS table, sends it to the mem table, and sends it back to the client. So that's the way reads work in Cassandra.